Hi, Texas Tim here, back with you for more LeetCode grinding. And let's see where we stand now. I have done 420 of the easy, and that actually is all the algorithm ones. I'm pretty sure. Let's double check. Difficulty easy. Yep. No available easy ones that I have not started. So we're working on medium. And I like to sort them from easiest to hardest. So let's get in there. Let's get in here. Number 1910, remove all occurrences of a substring. All right, well, let's do this. All right, given two strings, S and part, perform the following operation on S until all occurrences of the substring part are removed. Okay, so it's as we remove the substring part, then possibly additional instances of the substring part might be created. All right. Holy moly. I think this is a case for string builder. Let me just refresh my memory. And I like string builder for this because you can delete characters at certain places. Yeah, indeed you can. So let's try. Ooh, you can also remove the substring. Okay. Right. Okay, I think I'm getting a sense. I think we can move the string S into a string builder and then traverse the string from beginning to end. And if we find a substring, then we can delete it. Actually, I think that'll work. Is there also an index of? Yeah, of course there is. All right. So let's do a naive solution first. I like to sometimes just get a solution out there that works. Might not be the most performant. It's big O. Time complexity might not be that great. But it gets something down, and you get that momentum, because it's correct. I have a little acronym that I like to use to remind me of important things when I'm coding. It's CPRISM, CPRISM. And those letters stand for correct, performant, readable, idiomatic, secure, and maintainable. And I try to think of those six values or objectives or goals while I'm coding. And the first one is correct. It's got to be correct. If it's not correct, then it doesn't matter how fast it runs or whatever. If it's not correct, then you're out of luck. And a naive solution can be correct, and you can iterate on it. So let's do a naive approach, and what that is, let's see. We're gonna put it in. We're gonna do our string builder. So string builder SB, new string builder. Okay, and that's what we're gonna return. So, boom, we're like almost done. We just got to put some stuff in the middle. So while SB index, let's see, how do I want to do this? I want to know what the index is. Well, index is greater than or equal to 0. SB index of part. So what we're going to do is have a while loop that just keeps checking to see if that substring part is in there, and if it is, we're gonna delete it with this delete start and end indices. So delete index to index part length. Actually, well, we're doing a naive approach, so I'm not gonna try to optimize it yet. You know that old coding quote about attributed to Donald Knuth that optimization is the root of all evil, or something like that. But well, as you may know, the quote is more along the lines of premature optimization is the root of all evil. So there's nothing wrong with optimizing, but you don't want to do it too early, partly because you can get sidetracked from making your algorithm correct if you're too focused on the other letters in my little acronym. For me, that's probably the big one, is I get distracted by worrying too much about details early on. And I don't like to be distracted, right? So we're going to delete, and then we have to update our index equals SB. Oh my gosh, why did I do that? Index of part. And then we'll return it. So this is pretty naive. This should work, right? Let's see. Index. What is going? Huh. ABC. Oh my goodness. I created my string builder, but I didn't put anything in it. Oh my gosh. Oh my gosh. Okay. Let's submit it. Ooh, that's not bad. That's actually incredible performance for now. I mean, I'm just using inbuilt methods, you know, string builder and its delete method are doing all the heavy lifting. So would this be the best approach to code in like a coding interview? I don't know, maybe. I mean, look at that performance. If you're being hired for a Java developer position, why not show how well you can program in Java? Certainly there's a way to approach this in a more lower level way. And that's always something I think about. Is, you know, do we want to do a deep dive into details of, you know, kind of rolling our own basic, like rolling our own index of and rolling our own delete? Some, I don't know, maybe do both. If you have time in an interview, just do both. Let's look at these constraints and see if there's anything special to take note of. I try to look at the constraints before I hit submit, because sometimes there's a gotcha down there, but I don't see a gotcha there. So how could we improve performance? I mean, this is pretty high, 99.94. That's pretty amazing. But theoretically, we every time we do an index of, we have to look over the left part of the string again, and so there's a lot of repetitive looking. Let's see if so string builder does offer a from index. So what we could do is tell it not to go back all the way to the beginning, but just to go back the length of the string part from the last point we started, because that way, you know, if a new instance of part is created, it's not going to be further back than the length of the that string part. So let's try that. So the first time we're going to start from 0, but then after that we're going to start from index, and we got to make sure we don't go below 0. So we're going to do math max 0 or index minus part.length. So now we're giving it, what would it be? We're giving it a queue. We're giving the index of a queue to start just a little ways back. Let's see if this works. It'd be nice to get 0 milliseconds. Yeah, well, look at that. Isn't that nice to see? We squeezed a little bit more performance out of there. And it is, I mean, it's very satisfying that, theoretically, that it should be faster because you're not going over as many parts of the string, but it is nice to see the LeetCode judge proving that. Okay, so let's put in time complexity, and it is going to be ON. We're not going back over it too much, and something fell in that closet. I'll have to look at that later. So we're traversing S, and we're going back. Potentially we could go back every time, but in that case I think it would at most be 2n. It's never going to be n squared. Okay, put that for now. Space complexity. We're only getting smaller, but we do create a string builder that's the same length. Since we copy the input string into a string builder. Okay. All right. Let's submit it again. Like that. And I think I'm going to take out a naive approach. But let's make a comment. And actually, we don't need to put it there. Although, you know what? I bet that internally... Oh my goodness. Yeah, why don't we check? Let's see. This and... I think internally, if we pass it index of with just a single argument, it probably turns that into the index of with the starting index. I'm almost positive, but we can check. Let's see, JDK 13, and I was there just the other day. Yeah, here it is. And we're looking for string builder. This is, of course, the open JDK repository on GitHub, and there's string builder. And we're looking for the index of, okay, return super index of, okay, string builder is a instance of probably what, string buffer? Okay, so let's hop over to string buffer. Let's check index of here. Synchronization. Am I getting a little bit out of my depth? All right, let's go back to string builder. What is it a super of? Or what is the super of it? Compatible, no guarantee of synchronization. Isn't this fun, going into the JDK source code to verify what is actually happening under the surface? All right, extends abstract string builder. Okay, so let's go there. Okay, now we're talking. All right, what's the index of here? Index of. Yep. See? There it is exactly. Should I make this bigger? I like to do, let's do 125. All right, so string builder extends abstract string builder. And if you pass index of to your abstract string builder, it just turns it into index of with two arguments, including the second one 0. So I don't know how much optimization it would be to pass it the 0 anyway, but I think I'm gonna not, because if we add the 0, then whoever comes after, like imagining this is part of a code base, whoever comes later is going to say, why did the previous coder add a 0 there? And it's not going to be clear why you would do that. So, and the gains are probably so minimal that nobody would think somebody would do that. So I'm going to not do that. But down here, we will say, let's see, give index of, I'm going to, let's see what we're going to do. Only start searching from, what should the comment be? How about don't research from the start of the string. There you go. Maybe someone would, even better. No need to start from the very beginning of the string. There we go. And how about a little winky? Maybe that's silly. Okay, submit. There you go. I think, well, look, 0 milliseconds, faster than 100%. I think it's worth putting in the discussion. Let's do that. Why not? See, look, some of these are not 100%. Ooh, a recursive solution. That's interesting. And there could definitely be cases when that is valuable. Let's look at this basic implementation. Let's see what this person did. Oh. Okay, we've got a Boolean flag in play. Okay, so far, okay, it looks kind of similar to what I was doing. Interesting. Oh, so that's their index of, and they do restart from the beginning each time. So that's, a naive approach. I'll upload, why not? Thanks for putting your voice in there, person. Okay, but I'm going to post mine. Java 0, nice beats, 100%, very proud of that. Uses string builder, and index of with, let's indicate with a from index. There you go. Anybody who knows about index of and the second parameter from index is going to know right what I'm talking about. Let's post this. I'm really glad that went quickly. Sometimes these don't go very quickly. Let me take one last look at it before putting the ribbon on it. Delete. I'm going to add an exclamation point there. I wasn't going to do a winky, but I'm going to, oh, it's over here. There we go. And let me save. There we go. Ooh. I do, if I find that this same algorithm can sometimes hit a smaller memory footprint, I do like to record that information here just for my own reference. Gives me a familiarity with what kind of memory usage different algorithms or different approaches might have. Okay. All right. Well, that completes this LeetCode 1910, remove all occurrences of a substring. Thanks for hanging out and with me while I do it, and I'll see you on the next one.